you know. But it doesn't have to be that new. Just kind of something a little different that can target something. So, Niraj, right? Yeah. How, what have you given any thought to what you might do a project on?
I think we compare like if I told you about operating system, let's compare like Windows to like Mac OS.
Okay, like two real operating systems. Any idea like what kind of? Because you're going to need to target something very very specific as far. I mean, either there's two approaches. I mean, you could either do like a brief survey on the two, like a memory management type thing. Okay, so what are your kind of thoughts as to how you look at it? What I'd recommend is like writing a simple portable program that can run on both, so you can see the same program. In other words, like if you're doing memory management, for example.
Wouldn't that be the same? Like if I write a C++ program one, the difference?
No, that's the point. I mean they're execute. I mean like if you were doing a calculation or something, the results would be the same. But if you're like looking at, for example, memory management, memory management is meant to have like the same interface across both, but one of them might be faster, one of them might be slower, one of them. Yeah, so I mean, you really need to target. The easiest thing is to target a particular metric. Like if you're worried about performance, there's a lot of things that would affect performance, but memory management being one of them, you'd have to write something that's like allocating big arrays or filling arrays or something like that. Just like making some sort of example program where you start a timer, allocate a huge array or fill it with data or count up a number into an array.
Best language for them is C++, right? Java.
And just something portable. Yeah, not Java because it's too far removed. So in Java, you'd probably face like two layers of memory management where both of them are doing the same in the JVM, but the JVM is actually implemented, on the hardware. I mean, on the operating system. So the memory management would then affect that. So something like C, C++, something compiled would probably be the best because then you kind of eliminate at least a little bit of, something on, that aspect of it. So I don't know, but that sounds good. Something like targeting like memory performance or something like that. Doing maybe a little bit of background research on just like maybe even just Google, maybe not even like journal papers, but even just Google, seeing if there's anything that they say about how each of them manages memory, like differences or whatever.
Well, now I find like Mac with the same amount of memory.
No, yeah, I mean, if you can make it so that you stay within mostly free memory, you can look at memory management. If you start going into swap, then you need to make sure that you're kind of hitting swap at the same spot. Because it's not really fair to say, here's a Mac where I would start going into swap after 1 meg. Well, no, I mean, that's the thing is, I mean, you'll have to do some sort of normalization between the two. Actually, the new Intel Macs would be perfect because you can boot into both, but and have the same hardware on both. But I doubt you want to buy a like MacBook Pro for your your project. But something where you can eliminate most of the stuff, like writing in C about the same memory, or at least taking up some of the memory the same. But see if you can do what you can to narrow down to one metric, so you can say, oh, okay, well this one in this particular example allocates memory faster, or this one seemed more efficient, it didn't go to swap or something. But something along those lines, something where you can isolate as much of the difference as you can. But yeah, like a memory management between different like actual operating systems would be good. And I think targeting a specific feature would be easier than like surveying differences between the two, because that would just be a lot of legwork of looking through implementation documentation and stuff like that. But that sounds good. So something along the lines of memory management on two different operating systems. Another good option would be to do something with Linux, just because there's a lot more actual implementation details available out there. you may find that the differences between Mac OS and Linux aren't as great as those between Linux and Windows. Another good reason for doing Windows and Linux, like Windows and Linux, would be because you could probably boot it on the same machine, like on a PC or something. And I mean the performance of a Linux box and a Windows box on the same box is usually very different. So that might be a good option, or I don't know, something along those lines. That would isolate a lot of stuff. You just have to make sure you're not running a bunch of programs on, the stuff that loads in the background and stuff on one operating system. But yeah, that should be neat. I mean, right? But I do it by writing some kind of toy programs that can allocate a bunch of memory so that you have control over that piece of it. But again, a little bit of research on the implementation, like any notes you can find on how this operating system does memory as opposed to that one. Your book will be a good resource as well. Okay, so we have scheduling, burst times, memory, and showing your. You were interested in threads? Okay. Do you have an account on what is it, Qubit? You do? That might be easier than programming at home for doing threads. Okay. I'm trying to track down a very, very straightforward threading tutorial. Okay. Do you have any other topics that you might be interested in? We can look for something else, if I can find a straightforward tutorial, because the main thing is if you can get an initial kind of example application written. For your paper, all you have to do is change one aspect of it so you can look at an issue. So even like hello world, like with a basic threading hello world, that'll kind of get everything set up where you can just change little pieces. Because you will do a report on yeah, some background, but then also some issue that you came up with, yeah, like look what happened when I did this in this program, and you could say, and it's interesting because it relates to how we talked about threads this way, type of thing. So, but the main thing is getting once you get the first program compiled, where it's a basic program, it's usually a lot easier to just edit it, change little pieces here and there for your project, as opposed to the very difficult initial step of getting your compiler set up and all the tools set up so that you can make your first program. So, but you do have an account on Qubit, right? Okay, because I'll find something that I'm sure works on Qubit, like a tutorial, like a step-by-step tutorial that I'm sure works on Qubit, because that should get you kind of started with an initial program. And then you can look at it and then you can say, okay, that tutorial took me hours and hours and hours, and you could say, I don't think getting to the point of a project is a good idea or not. But usually these tutorials are usually very good if the machine you're working on is there's too much. There's probably too much on Google as far as finding things on threads, and a lot of it's usually very high-level programming once you get to, because see, most of the time if you're tackling threading, it's for a complex program. So that's usually what the stuff you see out there is on that kind of thing. But I mean, threading itself is doable as far as just looking at threading. It's just not done very often, so Google might have too much noise when you Google for it. Okay. Funny enough, that's half the projects already, so that's good.
It looks like we're a little behind as far as calendar.
Yeah, so
Change the project at all, or are we just gonna?
No, well, I mean, we have a little bit of buffer on two sections. On the calendar, you'll notice that the next one, the chapters on Linux and XP themselves, um, those are going to be, I mean, we have some kind of buffer there as far as, not going as deep into detail on those. Because it's really going to be a lot of rehashing some of what we've seen, but in a practical sense, in an implementation sense. So also, yeah, the project presentations, because our class is small, I mean, those 2 days actually might be quite sufficient since we have like around 2 hours in a class and we only have 6 people. So we might be able to, we might push some of it into that. But the main place I'm gonna take away from is the Linux and Windows XP. So yeah, the memory really, I mean, memory was very important. So I'm glad we spent extra time on that. And then missing a day on Thursday was definitely not good. Also, these next two chapters, 14 and 15, I somewhat disagree with them being separate. They look at them, and I'll go over that a little bit today. They're highly related, so we'll see. Hopefully, these will probably take less than 2 days as opposed to the 3 days that something like memory does. Oh, also, assignments. We did one on the main memory. The next chapter was virtual memory, and then the one after that is the one we're doing today, which is protection. Protection and virtual memory don't go together at all. So I broke out virtual memory alone into another 10-point little homework. So that one. And actually, this one's very small because the question is a little bit detailed. But I think it's very, very helpful as far as the question that it asks. If you look in, where is it? Assignment 5. Okay, it's just one question, which is, okay, it's one of those questions that is a go step by step through something. So it'll take a little bit, but it's question 9.4 in your book, which is, the question doesn't have a lot of content to it except for some numbers that give the specifics of what your memory looks like. So the basic question is, you have a computer, it has virtual memory, and it has physical memory, right? The virtual memory is kind of simulating more physical memory. So we have paging, and then they say, here's the memory size, here's the virtual memory size, the physical memory size, and the page size. And they say, I try to access this address. So this is kind of what we've done both in both chapters, main memory and virtual memory, where it's, I need an address, what steps do I go to get it? So you kind of exercise both what we saw in general paging when talking about main memory, and then also the little tricks that we do with virtual memory that kind of, is related to that. So it's really just the question of, what are the steps that we go through to access this one address? But as we've seen, that's a lot of steps. It's a lot of steps to go through that. So what I put on the question here on the homework is, it's just one question, so give a very detailed answer. I want you to go through the steps. The question says, note which ones are hardware and which ones are software steps, which I think is also very interesting. And then finally, just because it is just one question, giving a little bit more kind of demonstration of understanding the steps would be very very good for answering the question. So, for example, they don't ask for this, but some detailed discussion of, for example, TLB. Does everybody remember TLB when doing paging? Instead of going to the page table, you look at the TLB instead, right? Because it's kind of like a cache for page table entries. So you get to that step somewhere in the exercise, right? If you're accessing a memory address, you get to a step where you're going to look into a page table. So that would be a step where, maybe the TLB would be consulted. And can the TLB be used in situations where we have virtual memory, that kind of thing. So it should be fairly straightforward from the examples that we've been over and that kind of thing, but it is a little bit of writing for going over the steps and making these notes on the different steps. Okay? So, all right. Do you have any thought to your project?
I'm thinking of multiple.
Multiprocessing. So, in what context do you think you might? Some sort of like also doing something along the lines of threading and multiple
That's what I
processing.
wanted to talk to you Thursday, but that's what we needed.
Okay. So, as far as threading and whatnot, I'll have to break up as far as what threading topics come up. So, one of you might want to, I don't know. Let me think of some different topics that can happen in threading, and I think this will help because you can focus in on one particular piece of it. So, a lot of things come up there: synchronization, communication, that kind of thing. So, one of you might do synchronization, one of you might do communication. But on the basic threading stuff, it might be useful because you guys can maybe both figure out threading together.
I like synchronization.
Synchronization? Okay.
I feel very complicated on communication side. I don't feel very strong.
Okay. All right. Your name is Chinche, right? What's your name? Chinche. Have you given any thought to your project? Not yet. Okay. Any like general areas that are? Because so far we have people that have come up with some memory, a couple threading, multi-programming, scheduling. Some of the big areas that are still kind of left: memory management and virtual memory. There's what else? Another option, and any of you who've already thought of some ideas, even if you think this is better, another option is looking at some of the chapters that we don't specifically go over in class. Like one of the kind of biggest things that is left out in what we cover here is like file systems and things like that. File systems is interesting, are interesting. Networking, but not. I don't really, because there's a separate networking, like a lot of discipline, a lot of the networking discipline and the rest of the coursework that you could do in the computer science department. I'd like to stay. I'd like to not get too far into networking as far as projects go. I mean, it's obviously a very important operating system concept, but we have a lot of specialized classes for that, so I'd rather not do something like that. Another interesting thing might be virtual machines in general, like Java and things like that. As a separate topic, it's an interesting idea because Java is like an operating system in and of itself, and it's very interesting in the fact that it's an ultra portable operating system. In that, all of the things we've talked about thus far, you'll notice that Java has that stuff. Whether it's allocating memory and threads and things like that.
Is it going to be too vast?
I mean, again, any research any looking into research, you have this tension between breadth and depth. So if you're going to do something broad like Java, you're not going to go very deep into any of the different concepts, but you have to touch a lot of areas. Not everything, because like the language itself, you're not interested in because that's we're not in languages, but the VM, the virtual machine, is like an operating system in a lot of ways. So you'd be concentrating on that aspect of it. But yeah, at least look at some of the general areas, see if there's anything interesting, and then we can start narrowing it down, and that will almost get everybody on at least in a direction, so that we're going in different directions, so we cover a lot of different ground with the projects. But those are some of the big areas that are kind of not covered yet. Memory management and virtual memory, to me, are pretty big operating system concepts. So, but they can be somewhat boring. So,
Is there something we're gonna talk in this course about virtual machine?
no, I mean we kind of talk about it in passing. I mean it's virtual machine. I mean,
I like that concept, virtual machine, and especially Java.
okay.
I was thinking, I'm just writing one but
I mean, you're welcome
if
to.
we have at least one lecture or some part of the lecture.
I mean, as a specific, I just mentioned it because I think it's neat that it carries a lot of the analogies to operating system. It's not technically. I mean, there's debate as to whether you'd want to call it an operating system or not, but I think it's neat. And that's why I'm mentioning it. So, I mean, covering it as a specific topic in this class, I don't think so. But as a project, I think it's very interesting because it's not dedicating a lot of the class resource to going into a kind of peripheral subject. And that's what that's what the projects are meant to do, right? Is touch on subjects that we can't, directly focus the class on, but as a, additional exploration. That's what these projects are to do. And virtual machines might be a good one. So if you're interested in that, that might be an interesting topic. Now, you have two options there again, is breadth or depth. You can talk about almost, most of the concepts we went over in class and show how the virtual machine provides those types of services to a Java program. That's option one. The other option is picking a topic within Java and showing how it does that one particular topic like an operating system, like threading. So you can look at Java threading, you can look at threading in general, the theoretical threading that we talked about in class, and then say, here's how Java does that stuff. So,
because since we already have like threading.
So if you want to do something on Java threading, you're welcome to do that. And there actually is some coverage of that in the book to start you off, but you will need to look, your additional research will be things like looking at the Java documentation and looking at, Java pieces. Actually, for you, it would actually drastically simplify your project if you actually do go to journals, because a lot of people, I believe, I haven't really looked for it specifically, but I'm sure there are some papers written on the performance of Java threads versus other threads, and you can see comparisons and stuff. So that would be an interesting topic. So if you want to do that, that would definitely separate out into another area. Okay. So protection. Okay, so introducing the concepts for protection. Your book, I don't know, very explicitly separates these next two chapters into two different areas, protection and security. Traditionally, they're usually talked about in the same context, protection and security. They've chosen to separate it out. I don't necessarily agree that they should separate them out. I like the traditional way of looking at it just because we'll find that protection and security are very interdependent in a lot of ways. We'll see that, I don't know, from how they present, how the book presents the material, they kind of look at security more from an external versus internal standpoint. And what I mean by external and internal, we're talking about even on like a single machine. They talk about protection inside a machine. This is things that we've seen like accessing different memory areas. We didn't really go into file systems, but accessing different files, accessing different processes. That's what they see as protection, this kind of internal world of an operating system, whereas they see security as external forces as well as the people, that are going in, that are using these operating systems. How much you should look at them separate is, I guess, a philosophical question that you can draw your own conclusions. But they're going to talk about protection as a separate concept, and then we're going to look at a few different approaches to implementing to thinking about protection, as well as different approaches to implementing those those styles of protection. And you'll see that there's a lot of different both practical and theoretical concerns when implementing protection. Okay, so we'll look at these things like the access matrix and access control. These are different kind of general theoretical approaches, and then some practical ways of accomplishing this. Okay, we're going to look at protection. Actually, let's go to the next one, which is start looking at protection. Operating systems consist of a collection of objects, hardware, and software. The objects we're talking about are very, very abstract. They refer to pretty much anything in the operating system. Okay, some examples are things like processes, files, memory, right? All these different things that we work with our other, throughout all our other operating system concepts. Okay, some of them are hardware, some of them are software, some of them are software representations of hardware, right? We've seen all these types of objects and throughout our looking at operating system concepts. Okay, so we have all these different objects that we're concerned with in an operating system. Okay, so the idea behind protection is we want to be able to interact with these objects utilizing well-defined operations, interfaces, and procedures. Okay, we want to control how these objects are accessed, usually by other objects. Okay, how these objects interact. Okay, ensure that each object is accessed correctly and only by those processes that are allowed to do so. Okay, so this is the protection problem. We have objects, things like processes. They're interacting with each other. We've had processes access everything from memory, I/O devices, files, right? They all want to get at these resources. Okay? The protection problem is not how are we going to let them access those resources. How can they print? How can they write data to a file? The protection problem is we need to ensure that only the processes or other objects that are allowed to access these other objects in particular ways can do so. Okay? So it's not really a question of how do we write data to this file. It's can we or should we be able to write data to this file? Okay, and this is very important, especially in the different scenarios that we've kind of explored of utilizing computing systems. Not letting unauthorized or undesired processes access our resources is very important, right? If somebody alters our files while we're working with them, that could change our calculations, it could change the execution of our program, it could crash our programs, it could do all kinds of bad stuff. Okay, so that is the protection problem. Okay, and you'll see that this a little different from protecting yourself from things that are necessarily, I want to say malicious, okay? Protection kind of, it focuses more on when things go wrong, you know, maybe not with malicious intent, okay? It's not someone trying to get to your file and corrupting it. We shouldn't even be able to accidentally corrupt other people's files or other people's memory or other programs' memory. Okay? So that's what it's really more focused on. They leave the malicious types of activities to security problems. Okay? This is really providing the framework for safe operation of our different processes. Okay? And again, this principle that they're bringing up here, the principle of least privilege. Okay? Again, in traditional circles, when talking about protection and security together, this principle still applies. The idea is that programs, users, and systems should be given just enough privilege to perform their task. Okay? Least privilege means what you need to do your job and no more. Okay? This is a philosophy of how you design these protection systems. Okay, a guiding principle, as they say. Okay, and why? Why would you guide your protection system this way? So first of all, does everybody understand that it's bad if your process goes and fiddles with another process's memory? Right? If you mess with their variables, you break all their execution. So that's bad. Right? So that's the basic protection problem. So seeing that, right, this principle of least privilege, is this being able to only access, for example, your variables? Is that necessary to run an operating system where people have their own variables or programs have their own variables and you don't want anybody else to, and some other process coming in and manipulating those variables would be bad? I mean, do we have to put in mechanisms so that they can't write to each other's variables? I give you a flat memory. I give you memory. Okay, you have a flat memory space. Throw out everything we know about all this paging and all that stuff, right? Okay, we have a block of memory, and I say, okay, two of you go in and write a program that does independent. One of you is going to calculate square roots of a bunch of numbers. One of you is going to calculate, sums of a different set of numbers. Could two of you write programs that do that, given a big block of memory?
Possible.
Yeah. So what would you do? You pick a spot, right? You say, okay, I'm going to use the first half. You use the second half. We'll write our programs in C and whatever, right? We'll write some programs, pop in a bunch of numbers. One of you will sum those numbers. The other one of you pops in a bunch of different numbers in your half of the memory, calculates some square roots, prints out some nifty little output or whatever, right? Everything's fine. And we're running. Neither of you are messing with each other's variables, right? So, what's the difference between that and a protection scheme? And how does that relate to this idea of least privilege? First of all, in that scenario, do the two of you have least privilege? No. Why not? You said yes.
The reason I said because we separate our side stuff or something. Our minding our.
Can you write into the other set of memory with your program? Yes, you could, right? I mean, you won't, right? Because you're a good guy. You don't want to mess up, someone else's program, right? But you can write into the other memory area. In other words, you have privileges that are beyond what is necessary for you to run. Right? You being able to write into another area of memory is not necessary for you to write your program. Right? An agreement between two programs saying, oh, I'll just write into this half and you write into that half is not least privilege. Right? That's a policy that you all agreed on and you decide you're not going to do it. In other words, out of the goodness of your heart, you decide, I'm not going to write into this other half of memory. But you do have privileges beyond what you need. Okay? So in some ways you have a protection scheme. Your protection scheme is, let's agree not to write on each other's memory space. Okay? But your protection scheme is not implemented utilizing this principle of least privilege. Okay? And as such, your scheme is harder to enforce. Why? Because the only difference between someone following the scheme and not following the scheme is changing little pointers that point to different variables in memory. Right? Now, you could violate that principle, that policy maliciously. You could say, I want to mess up this other program, so I'm going to poke around in their variables. Right? Or you could do it accidentally. Right? You're writing your program, you accidentally put in the wrong address. Next thing you know, you're accidentally clobbering the other person's data. Okay? In both of these scenarios, something like a principle of least privilege prevents that from happening. In other words, it enforces the policy in a stronger way. It says a principle of least privilege would be, here's your program that you're writing. It only has access to this half of this memory. Okay? You're not even capable of writing into another set of memory. The other person has a similar set of rights, but they're only allowed to write into that particular set of memory. This is different from just agreeing that I'm going to keep my pointers over here, you're going to keep your pointers over there. Okay? This principle makes implementing protection easier. Why? Because if you give a process, a user, an object, only the rights that are necessary for it to accomplish its goals and nothing more, you don't have to worry about different combinations of activities or different operations that you didn't think of violating the policy, the protection policy. Okay? You don't have to worry about the programmer accidentally putting in the wrong address. You don't have to worry about the programmer trying to access the other person's variables. The reason being is because if they do that, the only thing they'll do is break their own program. Right? They'll violate it and they won't be allowed to do it and their program will stop. Okay? So, how do we think about this least privilege? Okay? And what we introduce here is the idea of kind of privileged domains. Okay? So, how they define these domains are, we have different objects and a corresponding set of rights to that object. So, now we're kind of getting more into detail of, not necessarily the objects, they're still kind of abstract, but these rights that we can have, okay? These rights that they talk about in these privileged domains are referring to this third point in these goals of protection. They say, ensure that each object is accessed correctly. Okay? The correctness of your access to an object are these rights. In other words, you're accessing them in ways that it's been predetermined you are allowed to access them. So, me accessing the object of a file, for example. Okay? Me reading to that file or writing to that file, both of those are forms of access, right? If I read from the file or write to the file, I'm accessing the object in some way. Okay? But if we get more specific and say, I only want you to read from this object, me writing to that object is accessing it incorrectly. Me reading from it is accessing it correctly. So being specific with how we are able to access them is this idea of rights and accessing correctly. Okay? So, notice they, in this diagram, which didn't come out very clearly, but we have a bunch of objects, and then we have these little set notation of saying what are their rights to that object. So what they've done is they've kind of done like a Venn diagram that kind of shows how the access to these different objects fits into domains. Okay? The domains are basically a collection of access rights to particular objects. So if we look at the diagram, D1 is very simple, right? D1 has different types of access to 3 specific objects. Those are O3, O1, and O2. Okay? O3 and O1 we can read and write to. Okay, that's the set of access rights we have. Okay? O2 we can execute. So looking at that diagram, because it's separated out, the D1 is separated from the rest, we know that none of these other domains have the right to read and write object 3, read and write object 1, or execute object 2. Okay? But then the kind of breakdown of the domains can be a little bit more complex if we have shared rights between 2 different domains. So here we have D2 and D3 sharing a right to object 4. Object 4 can be printed to, and both of these domains have access to it. Okay? And then they each have their own specific rights that are separate. Object 2 can be written to by domain 2. So looking at all of this, we know what we can do in each of the domains to each of the objects. So, looking at access this way, how do you think we'd use this to implement protection in an operating system? Let's think about, for example, what we were talking about with 2 programs sharing some memory. Okay? We had a big block of memory, right? And we had a program 1 and a program 2. They want to use that memory and they want to do their own little calculations and use their own variables. Okay? So, a big block of memory. I guess my question is, what are these domains? What are these objects? What do you think we'd make objects, and how do you think we'd use these domains? What are some candidates for objects? What do you think would represent an object? Potentially a program could be an object. Memory could be an object. Do we need to make all of the memory an object? Right. Each piece of the memory could be different. How would you break up the memory into objects in this case? Okay, so we'll cut it in half. Yeah.
Are the programs like identical in size and such?
That is,
So would it be wrong because it's cut in half? Because one might be more than the other?
sure.
What are you supposed to do like that?
That's a memory allocation problem. We're not worried about that. We go into a bunch of different schemes from the previous chapters to decide that. Okay, so I cut it in half. So, let's It's label fingers, label fingers. Object 1. Okay, object 2. That's object 1. Okay, so we'll call that object 1 and object 2. Okay, now, I have the option of whether I want to make P1 and P2 objects. Let's not for now, it'll keep it simple. Okay? I have an object 1 and I have an object 2. What do you think I'm going to do with those? What kind of rights do you think I'll need to those objects? Let's not concern ourselves with who is going to get to access those objects. But if I'm writing a program that does stuff like loads a bunch of variables into memory, sums them up, or calculates square roots, what kind of operations do I need on the memory? Okay, so read write at least on the data, okay, and execute on the program. Let's do all three. So we'll say read. We're going to need object 1, right? We're going to need read, write, and execute on it. Right? So that is in the notation that we saw up there. Okay. On the other one, we'll also need that, right? Object 2, we need read, write, and execute. Now, domains. Let's not really worry about how we're going to tie those up to the programs, okay? But these domains kind of say which ones, some domains share some privileges with other domains. Some of them do not share privileges with other domains. So, do we have crossover between, in other words, if I have two domains, should I put both of them in one domain? Should I put one in one domain and one in the other? Should I have one in both domains? How would you draw the circles around these? Okay. If I access object 1, in other words, I'm putting variables in, I'm reading variables out, do I need to access object 2? No. If I'm reading and writing variables to object 2, do I need to read and write variables to object 1? So what does that mean? I don't need to do anything with the other object if I'm accessing one of the objects. So what does the Venn diagram look like for negatives? Right, two disjoint sets, right? Two disjoint circles. Call this D1, the first one, and then we'll call the second one D2. Okay? So, how would we make this work? Now, if I want to say that program 1, I want it to use memory section 1, how would you do that? You tie it to, you give it privileges of a domain, right? If we tie program 2 to domain 2, program 1 to domain 1, what are we stating by that? What are we specific? When I do the operation of program 1 has the privileges of domain 1, what are we saying? Execute of this section of memory, which is the top section of memory, which is an object. In other words, if you're given the privileges of domain 1, that means you can read, write, and execute object 1. Object 1 was a representation of the top part of memory. So, tying these together, we've implemented our protection scheme that we mentioned before. Program 1 operates on one half of memory. Program 2 operates on the other half of memory. Okay? And you can imagine that if we implement this in a way that the operating system is enforcing these little Venn diagrams, right? What if program 1 tries to write to the memory section that is represented by object 2? We have all the information we have all the necessary information to say, no, you can't do that. I'm going to terminate you, I'm going to stop you from doing that, whatever. Throw an exception, whatever mechanism you want to use, but you can say, you're trying to access object 2. I'm looking at your domain of privileges, nothing about object 2 is in there, done. Okay? Oh, you're trying to write a variable in the top half of memory. That's represented by object 1. I look in your domain of privileges, you have read, write, execute to object 1. It's all good, you go. You can play, you can play with these variables as much as you want. I've looked in your list of privileges. Okay? So this is a way of looking at these privileges and domains, these protection domains. This is a way of looking at the protection policies. Okay? So,
If it's so, then there shouldn't be any problem. But when the problem comes, I mean, if that's the way it's set, there shouldn't be any problem.
yeah, we've solved the problem.
Yeah. But when the problem actually comes, I mean, when is it like,
We had the problem before. We solved the problem. If we can implement that, problem solved.
so it's like restricting one not to cross the border.
Sure.
So is it possible if food is still there?
I mean, if we implement it wrong or something like that, yeah. But what we're talking about, you can't implement that in a computer. You can't implement the Venn diagram right? There's an implementation that would occur here. Someone would program an operating system to reflect this. They could do it wrong, right? Which would be bad. And then there would be a problem. But this is the solution to the problem that was there before. The problem that was there before was none of this Venn diagram stuff was there, and program 1 can just go wherever it wanted. So we solved that problem. It's a whole other problem of how do we implement this. It's another whole different problem of, is this enough flexibility for us to do all the protection that we want to do? Right? And then also, another thing that comes up is checking all this stuff going to make it so that our computer is unusable? Okay? That's usually one of the biggest conflicts you're going to see between protection and security versus performance. Okay? Because these are all additional checks that we're doing above and beyond just running programs in memory, which we've already seen is hard, right? Just running programs at all, we have all of this technology and theoretical concepts backing that up. Now we're adding on another layer, which is not only how do we do all that stuff, but can we do all that stuff, or do we want to allow that stuff to happen?
If we wanted to say that domain 1 had allowed access, I guess, to object 2 also,
Mhm.
just put another, how would that look?
Like, okay, let's actually put a similar twist. Let's say we want to communicate between these two processes. One way to do that is shared memory, right? So here's what I'm going to do. I'm going to put in a little section of memory in the middle. Okay, I'm going to call that O3. Okay, this is going to be like a mailbox that we can talk between. Okay, so if I want to talk between them, what would I do? Well, I'm going to just erase the domains first, because we're going to redo this. Okay, but I have another privilege here. O3. What privileges would you give O3? Read and write, right? Which one did we leave out? Execute. Because we know we don't have code there. We're just putting data there to communicate between. So, principle of least privilege, only give exactly what is necessary. Would adding X there prevent us from doing our job? No. We could still do read and write if read, write, and execute are there. But it would lead to the problem of maybe processes using that object to execute things when that's not what we want. Okay, so least privilege. So this is another privilege. So how would we implement the sharing of that object 3 memory? We create our domains so they look like that, right? Where they have a shared crossover point in the middle. This is the top one's domain 1, the bottom one's domain 2, and then map the two together. Okay? At this point, if you are program 1 and you say, oh, I need to pass a message to the other program, I need to write to a variable in the middle area of memory, right? So the operating system, if it implemented this, would say, oh, the middle area of memory, that's object 3. Let me look in your domain. You have read-write access to object 3. I'm going to allow it. Okay? So, now back to the other example that Lindsay brought up, which was, what if I wanted program 1, well, you said program 1, I wanted to access the bottom half of memory, which is represented by object 2. What would that look like? Okay, so object 1 was the top half, read, write, execute, right? Object 2 is the bottom half, read, write, execute. Right? Domain 1, domain 2. Right? What if, in that example, we don't want program 1 to execute in domain 2. We only want it to read and write into domain 2. How would you draw that?
You have to create a new, I don't know what it's called.
Privilege.
Little-
Yeah, the object with the rights.
Yeah, just be O2 RW.
Okay, O2 RW. Okay, so we got one thing. What else do we need? Oh, I'm doing a separate diagram.
Oh,
We're not touching that one.
alright. Oh, we're talking about E1, right?
Talk about both.
Or one, yeah,
Should still need O1.
O1 would still have
read, write, and
read, write, execute. We're missing something.
Still need O2 rewrite. What was the problem again? We wanted O1 or,
Just execute.
oh, right.
Why?
Because it's included in the.
This is domain 2. The bottom is. This is domain 1. Domain 1 is allowed to read, write, and execute to object 1. Domain 1 is also allowed to read and write object 2. Domain 2 is allowed to read, write, and execute object 2.
it's like Unix.
Huh?
Unix.
Yes, Unix is an example of this type of scheme. Right? It's actually a very limited version of this scheme. Because here we've shown we can arbitrarily draw these circles, right, create these domains, which in Unix, like for example, and I assume you were what you were thinking about when you said like Unix, you were thinking about the files, right? When you mess with the file permissions, you have something similar to this, read, write, execute. But what are your domains?
Like the username and group ID,
User, group, and
what's that?
Administrator.
user, group, and
Everybody.
everyone. Okay? Other. Okay? So, this will cover this whole thing. What do our domains look like in Unix? Let's go on this side. Pellicer. Group is CS. Okay? And my permissions everybody understand these first few bits here. RW dash, RW dash, R dash dash. What is that saying? User, usually called owner, can read, write, and not execute.
Same thing for group.
Group is the middle. And then others can only read, right? So, domains. Go. What's the object? What are the rights?
You should have just one is read and another one is
Domains. Using the universal gesture for draw a circle around everything, like Lindsay just did. I drew a circle around everything. What's the domain for this? Huh? User and group. We need another domain. Is what? Okay? Just around read, you have other. I added a little X bit to user.
One more on the file.
What? One more
file
what?
one.
Okay. File one.
Execute one.
Okay, so we have another privilege, right? File one, execute. Domains.
read. Make another big circle.
Okay, so I'm going to take U off there. Let's move G, the little corner there. Okay? Now, what should U encompass? Right, big circle, right? So everything here becomes U. Okay. You can see we're limited somewhat in that The domains, we have 3 domains to work with, 3 privileges in each domain. Okay, there's actually more in Unix, but I mean those are the ones you're usually concerned with. Okay, but does everyone see that this Unix example that we're looking at, this is an implementation of the domain concept, right? We drew these things over the diagrams for these domains and privileges. We drew that without any concern for how are we going to program this, what operating system can we put it into, and that kind of thing. This is the concept, the idea of creating these privileged domains, privileges, rights to objects, and whatnot. Okay? This is, let's take this domain concept and let's put it into the file, the file privileges on a particular operating system. How would we manipulate these domains on Unix? We'd run commands like, change mod, chmod.
CMOD.
Huh?
CMOD.
No, chmod. Okay, that's how you change these bits. Okay, and by running that program, you draw different circles between these. Okay, these different bits. Okay, so this is an implementation. Okay, does this implementation have the full power of what we saw here? No. Okay, it has a specific set of operations we can perform on these different circles and bits and whatnot. Okay? The other thing that you have to keep in mind is that before, when we were looking at memory, objects, and programs running in memory, what did we do to let a program write to memory? Well, we created our nifty diagram that has the domain and the memory objects in it. But then we were about to run a program, so what did we do? We gave it one of the domains, right? We said program 1 has domain 1 privileges. Program 2 has domain 2 privileges. And now all of a sudden they can run. What kind of similar thing would we do here with this file access? User, so connect it to something. What do I connect that to? Right? If the answer is this S-Pellicer, right? This username that's associated with the file. If I am that user, in other words, if my user comes in, okay, because I am the user associated with this file, I get some domain privileges. These domain privileges now tell me I have execute access, I have read access, and I have write access. Okay? If you're not user S-Pellicer, but you are in the computer science group, well, your group being CS will get tied to the group domain. Well, you go through your little circles that you've drawn, you have write access, you have read access. Okay? I've looked at your user, you're not in the computer science group, you're not user Stephen. You're other. Here's the domain that you're tied to. Okay? There's the objects, there's the rights to the objects. There's the domains which collect these rights and objects together, and then you associate the domain with an actor of some sort. That's the process that we do all this. And this is all a formal, systematic way of us expressing, here's what the least privilege is that I want to give different users, programs, anything when they're operating on in my environment. Okay? I have this expressive language to say, here's all the ways that you can interact with objects, and I'm going to express the least amount of privilege so that I can enforce my protection policy. Okay? Now, let's take a quick break, and then we're going to talk about, what's that? Oh. We're going to take a quick break, and then We're going to spend about 15 minutes looking at two general domain implementations. I think I got a separate email. Yeah, the homework submission. Yeah, I think I got it. If I don't, I'll email you back. Go when I go through them.
You know anything about JDBC?
Z or G?
JDBC.
Oh, JDBC.
Java database something.
Oh, connector database JDB. Oh, okay, yeah, I gotcha. Not specifically, but I mean that whole class of things: JDBC, ODBC, all these different styles. What I know about them is I'll look up the library, the actual driver for the database I'm using, and then they're gonna all have like a similar set of calls that you use to interact. So like ODBC is the same way. You choose a backend driver that you're gonna use, and then you just have a bunch of basic primitives like create a record set, iterate through a record set, that kind of thing. So.
Just give the project a database. It's like, here, go learn JDBC.
It's not. I mean, just two pieces you need to know. You need to learn the API, the front, and then just how to kick it onto a database. So you're supposed to use it with like Oracle.
Yep.
Okay. So you just go find out how do you do the connection string for Oracle. So that's the opening the connection, and then you just have to get familiar with the idea of you create a query, pop it on, execute. It'll go submit the query, and then all your results will kind of be sitting there in the connector. And then you could say, okay, it's a record set, next record, next record, next record, next record, and then there's another set of APIs that say next field, next field, next field. So it's just a way of iterating through result sets and stuff. But it's all completely generic where you send queries out and then it may or may not return a result set.
So what actually shows the result? Is it Oracle or is it?
These abstract APIs that represent a row, a field, that kind of thing. But it's not like a set. I mean, it's a set. So you're responsible inside Java for iterating and stuff like that. So the idea is I'll give you an API that lets you iterate, that lets you look at fields, stuff like that. So typically what it is you go in and you execute a query and then you kind of know what comes back, or you can ascertain what comes back by using the API. But normally what it is, like you'll say select name, phone number from employees or whatever. What comes back is a row set with fields in it. So then what you'll do is say, okay, well I already know that there's name in there. So what I'm going to do is I'm going to say get name from rows. and it'll spit out a string that says that person's name. And then you'll say, okay, next record, get name from row. It'll spit out the next person. So it's usually just, it's a system of just, you trigger it, you make a call to go to the next row, make a call to go to the next row, and you just go get the fields.
Okay.
I mean, that's it. I mean, and it's just a matter of what their specific API is for each of those. So what you do is you go to the JDBC site and you like look at the basic things. But you want to look for a record set, the query object, and then fields, how to access fields. Like accessing fields are going to be methods off of the record set object. There's going to probably be a connection object, a query, or command object, and then a record set object. So the typical idea is you set up a connection to an Oracle database. You create a command object based on the connection, so that you'll say, do this command on this connection. And then you'll say, when I execute this command, what returns is a record set object. And you take that record set object,
And you actually have to.
get away from all that stuff, and then you go, okay, I'm going to start spitting out data. So the whole end goal is to get a record set.
And if you want to update, you just have to.
Usually, there's a cut. Depending on the capabilities of both your database and your connector, like JDBC should support this, I think. Some of them support things like what are called like cursors, where you can get like a row. You should be able to manipulate the record set and then hit a method and it'll update the record set. So you can get the name field, alter it, and then trigger update and it'll push it there. But that's somewhat dependent on, normally the fast and dirty way to do it is you just create another command object that is update row, update, just a regular SQL statement that updates, and you just trigger it and it'll update it. But the real fancy way is to just deal with everything as this abstract row set and do stuff with it and then update or query, or in other words, have an object that represents the whole table. But it gets complicated when you get to the point where your query is like a bunch of joins and stuff like that. If you were to update a field, what does that mean? Should it ripple through all the
Yeah.
different,
I don't think it's going to be that complicated.
So the typical thing though is you don't do any of that. You just create, most people just use JDBC as a very fast and dirty way to have SQL access to a database. But it's capable of a lot more, which is having a very abstract connection to a database. Because the more you execute raw SQL on the database, the more you're dependent on that SQL being correct and all that stuff. Whereas if you make it abstract, you can just deal with the row set and you can do drastic alterations to the back end and never have to change your program.
Good in theory.
Theory usually takes at least 3 months longer. Doing things in theory. Okay. I'm more interested in, you can look at this Multics domain implementation in your book. Multics is Multics used to be like like one of the preferred learning operating systems out there. I don't know. I'm of the school that's kind of moved on to Linux, as far as Linux was in a lot of ways written in response to Multics. Like didn't like Linus Torvalds didn't like Multics, so he wrote his own. And then now Linux is very big and Linux is very popular, so that's why it's. I don't know. But Multics was apparently a very good teaching operating system because it had more theoretically rich implementation, whereas Linux is very practical implementation. Okay. But you can read about Multics in your book. Access matrix is a little bit more practical. It is a way of implementing a lot of these concepts we saw with these Venn diagrams and everything. It does it in a way that is actually a little bit more straightforward, and matrices, right, are a lot more computer friendly, right? Drawing circles around things, no good, right? Doing that in program code is no good. So matrices are a better way to do it. So the idea is rows represent domains, columns represent objects, and then in the cells, right, inside the row, the cells that are represented by a row and a column, you put in what the different rights are. Okay, so in the example here, we have different domains accessing different objects. Here they're probably files. Oh yeah, so F1, F2, and F3 are files. We have a printer object, right? All manner of things that we might want to access. We have different domains, and if you look at the intersection between a row and column, you'll see you have a little text there. Okay, and the text there will say something like read, print, execute, read, write. Okay, so this is a very straightforward way of implementing this more complex diagram type view in a nice little table. So we can imagine how we'd write programs, right, that use this privilege table, right? If I'm about to access file 2 and I'm associated with domain 3, right? I'm a user or program that's associated with domain 3. Well, I'd go to the table, I'd look up, I'm in domain 3, I'm accessing file 2, look at the intersection, I have read. So if my action is reading, good to go, just let it go. If not, I could throw up some flag or whatever, terminate the program or do something that says, no, you can't do that. Okay? So, there. That's just explaining what we just said. Okay? So, then we get into the idea of how do we get all of this going? In other words, we don't want to have to, from installation of the operating system, to know all of the access rights that need to be on all of the objects in the system, right? So a lot of times, one of the biggest needs of these systems is we need a way to modify the system as it goes. Okay, so we want to expand it into a dynamic type of protection scheme. So what we need are operations to add and delete access rights. What's that?
Like CH1?
Yeah. So yeah, exactly. So chmod is one of these types of programs that might be able to dynamically change the access rights as we're going along. Now, the problem is that now we have a whole other question of how do we, who do we let change these different access rights? Well, being able to change access rights is an access right in of itself. So a lot of times what you want to try and do is build the scheme for modifying itself into the system. Okay? So we have this idea of owner, the ability to copy, control, or transfer access rights from one cell to another. Okay? And that's significant in that, let me see here. Okay, here we go. So, actually that's not, let me see if we have a good example of, okay, so here, what they're saying is that we can potentially change, this copy? No, they don't have a good example of this mechanism right here. But the idea is, in some of the columns and rows, what you do is you add in the ability to change some of the cells within that row or column. So the idea is this: if I have a file like this file, for example, right? A higher level privilege that we might want to allow for the owner is an owner can change the privileges of any of the other domains, including its own domain. So we'd have something along the lines of an owner privilege inside here. Now that owner privilege is a special privilege that says I can change these domains. Does that make sense? So if I say that you have owner privilege, well, that means that now one of the operations you can do is erase the lines that are these domains and move these objects around. Well, we'd be doing it in a nifty table type of format because it's easier. So the idea is that if you have a table, if you have ownership of either a domain or an object, you can, for example, with chmod, right? Since I can change the read, write, and execute of the 3 different groups, what I'm saying is that on a file, if I'm owner, I can put in whatever entries I want into each of these cells. Okay? If I say change mode, group can now execute. What I'm saying is one of these domains represents a group. I'm saying I can add execute into the cell. Does that make sense to everybody? Okay? So through using particular privileges inside the system, we could potentially change other privileges in the system. Okay, which is very powerful because you can start off even with objects that don't have any privileges to begin with. You have a way of bootstrapping the system of saying, okay, you're the owner of the object, I'll let you dictate what privileges to put in here for at least these particular domains, like owner, group, other. Okay? But what you want to be careful of is the ability to change the privileges in a domain or in an object is very powerful. So you want to be very, very careful about who you give that privilege to, because it doesn't do us any good to say that something can only read a file if we also give them the privilege to add write in. Does that make sense? So if you say, okay, you're restricted, you can only read this file, but I also gave you owner. Right? You're no longer just restricted to read because you can also perform the operation of adding write and then writing to the file.
That's the same thing you did over there, though. Like at the first place, you were like, the user can only read and write. I mean, the owner.
Right.
But he can make it execute if he wanted to.
Sure. I know, that's very powerful, is what I'm saying. And you want to restrict, like you don't want to give that privilege to other. Do you see what I'm saying? So, seeing that owner is very powerful, you want to make that really, what I'm saying is you need to be very wary of least privilege, especially with powerful things that alter the privileges of other domains. Okay? So owner, right, the ability to write any privilege in there is obviously the most powerful privilege you can have. Right? Because no matter how good any of the other privileges are, you can just add them using something like an owner. Okay? And then you also have the idea of copy, transfer. So the idea might be, I'm going to give you read access. I'm also giving you the privilege of transferring read access to someone else. So I could give you the privilege of, you can read this file, and I'll put kind of an additional thing that says read transfer. Now you can say, oh, this other user, I'll give them read access. And this other user, I'll give them read access. So now you have the ability to, at least for that one privilege, give out read access. Right? And then you have the question of, can you give out read transfer access? What do I mean by that? Does everybody understand the idea of a read transfer access? In other words, you can read, but not only that, you can also grant read to others, to other users.
What happens to you?
You still get it. You still keep it. Everybody understand that concept? Okay, I'm a user. I say I have read access to this file, but I also have transfer access. I can give you read access. Here, done. Okay, now we can both read the file. Right? Give you read access. Now we can both read the file. Right? All of us can read the file. Okay. Now, what do I have to be careful of there? Do I want to give you read access, or do I want to give you read with transfer access? What's the difference?
You can transfer to someone.
Right, if I give you read with transfer, that would mean now you could give out read access to other people. Right? So, I mean, the idea is that these abilities to change, see, me giving out, being able to transfer read access, that's giving me at least a limited ability to change the rights inside this domain, right? I mean, inside this in this object. So, it's more powerful than just the basic rights of I can do these operations, because we're altering what operations can be performed. Let's see here. Now, this other diagram here, okay, is interesting in that they're giving us the ability to change domains from certain domains. Okay, this is another very powerful technique. In that, like, for example, if you look at between domain 4 and domain 1, right? We find an entry that says switch. So the idea is that if I'm in domain 4, this switch capability says I can switch to domain 1. Well, what does that mean if I switch to domain 1? Now I can read these two files, which is not very exciting because I could write them before. Why would one want to do that?
So you don't accidentally write them.
Sure, that's a great reason, right? Is even within myself, I might not want to, might not want to do something wrong, right? Like we've been thinking of this as two different processes or users kind of battling each other, trying to get access to things. But sometimes it's even ourselves. Switching a file to like read only is a good idea sometimes, because remove all is could accidentally do something really bad to you. So it's still powerful to even lower your privileges. Again, that principle of least privilege. I don't need to write these files, so why don't I just switch myself to a read mode? Okay, you just have to be careful, because can you get back to a mode where if you need to write? But and then so does everybody see this idea of domains are kind of like objects themselves, and then this is saying that this domain can interact with these other domains through this operation switch. Okay, so it would let you jump through, and then that would go to D2. D2 would finally let us get back to D4 or D3. Okay, now in implementation, this switch operation may be more detailed. You can only switch in this case or this scenario, or there might be some criteria that needs to be met in order to switch, but here we just have the kind of vague notion of these domains can move from one domain to another. Okay, but in actual implementation, this may be something very specific where we're going through, for example, this D2 domain that we see in the table. It might be a print program, like a print daemon of some sort, right? So we can go print, but the only operations available in that print daemon will switch us back to our other domains when we're done, or we can only go back to a domain we started in, or there's some mechanism inside that printing program that controls the switch back, because we don't want this to just be a freewheeling, you can jump from any domain that you want, because then a lot of this table becomes, if you can jump to any one of them, you can be in any of the domains we've seen. You can, right? We can trace our way through to being any of the domains. So it would kind of make it useless. But if you can control how that switch happens, you have a lot of flexibility with these domains. Okay? This, again, is kind of along those lines of what we saw with altering domains and whatnot. Okay? This is an example of that, transferring or copying privileges. What they're doing is they're saying there's a little star, which means that you can transfer those privileges. And they're showing that they created a, what did they do? They transferred read privilege from file 2, they transferred it into, they copied it into domain 3. And notice they're very, very careful to take the little star away when they copied it. Right? That way, domain 3 can't go and grant read privileges to other domains. Okay? And then owner, they're saying you can do whatever you want. Oh, and then this is a combination of two of those concepts, right? The idea of I can switch from one domain to another, as well as potentially control domain 4. In other words, I can alter domain 4's privileges. Okay? So, that's the main part of this chapter that I wanted to go over, was this idea of an access matrix and these domains. Okay? We'll look at some specific examples of using those matrices in an exercise, but that's the main thing, because I want to talk about security kind of in the same chunk. So we'll probably talk about that on Thursday. And then we can see how the two mesh together. Oh, Chinchilla. Security might be another good area if you have any interest in that. I have to warn you though that I used to do a lot of security, so I'll be very tough on a security project. But
I will let you know.
yeah, I mean, and again, if you can just give me a general area, I can also offer some suggestions as to specifics, like a specific project within the general area. Okay?
Can you go ahead and read the Java threading and make it final Thursday?
Sure. Yeah. I mean, in the threading section, I think there is actually the last part of. It's the threading chapter, and we didn't go specifically over the threading chapter, so you might want to read some of the beginning. But I think they have. There we go. So some of the Java threads here. You know, you can look through that. I'd look at some of the rest of the chapter though, because we didn't go specifically over threading.
Okay. So I'll let you know Thursday.
Oh, yeah.
Final.
No problem.
That's what I'm going to do.
Yeah.
'Cause
It should be
I like
interesting.
that,
I mean, it
yeah.
should be interesting just because it's also a little more practical than some of the other concepts. Because I mean, you probably will
Actually,
eventually.
threading is like overall same for any kind of process or any kind of
No,
thing.
absolutely not.
Because the reason I say that last semester I did some work on threading. I had to write a program on thread, but I had to read a lot from the internet. So that's why I thought probably I could do some.
Oh yeah, I mean definitely. No, but what I'm saying is, threading is not just threading.
No, what I had to do, I had to do on C programming.
Mhm.
So that's why I said that. The concept is same though, right? That's what I meant.
Yeah, I mean
Thread
threads are
concept
threads
is
in
concept,
the
yeah.
sense that they're multiple threads of execution, but how they're implemented, how they're
Oh, that should
used,
be
and all that
different
stuff.
for everyone.
No, I mean even if you have the same program running, I mean the same C program with threads running between two different operating systems might implement those threads completely differently.
Right. But the main concept is same, that how it works, thread works.
The main concept is the same as anything else, which is it's two processes of execution that share memory. But that doesn't say anything. You know, saying that you have two threads of two execution streams that share the same memory space. That doesn't say anything.
Anything, right?
So that's the only part that's the same among any threads. You see what I'm saying?
Yeah.
Everything else is different.
I
How you call them, how you create them, how you manage them, how the underlying system deals with them, all completely different.
I'm going to read.
But those are the details that are important. I mean, those are the details, because, I mean, it drastically affects how the threads perform and what you're capable of.
Can I ask you one personal question?
Sure.
You have to answer.
Okay.
What's your PhD topics, thesis?
What is my research area?
Yeah.
Distributed computing and asynchronous computing and multi-programming. So all this threading, I mean, it's basically different kind of instances of all this threading, multi-programming, and stuff like that.
So I'm mostly distributed systems. So I do a lot of parallel algorithm type stuff and a lot of networking.
Have you find out what you're going to teach in CSC?
I put in my request to Dr.
I saw
Sundaram.
so many of them like they're not listed teaching.
Oh, he hasn't assigned them yet. He hasn't
No,
assigned them
lots
yet.
of things, still, and probably they have teachers shortage or something.
What's that?
So.
No, I mean they
lots of
haven't
courses, yeah,
assigned
They
them
haven't
yet.
assigned anybody.
Right.
That's right.
So he hasn't assigned any of them yet, but I put in my request and I'll probably be teaching networking
Good.
next semester. So.
Please do so.